Hello and welcome. I'm going to try once again to share with everyone what's going on in my world. I would say that I'm going to help teach people how to engineer signs, but I'm not sure if that can be taught. So probably all I can do is present what I'm working on at the time and give you an idea of what I was challenged with and what I came up with as a solution. Maybe take it from the cradle to the grave. I don't know. I've been in the sign business 37 years. Hands-on. But here I sit today engineering signs for a large electrical sign company. And every day they stack a pile of work on my desk and expect me to hurry up and get it done. Can't say I blame them. I can only imagine the size of the payroll there every 2 weeks. All right, let's get started. So I know it's hard to tell what you're looking at here. I'm using SolidWorks. I'm trying more and more to use SolidWorks to begin with the end in mind, as I like to call it. Let's go back to the Corel drawing. Okay. Here's the job. Put a sign on this motor crane. All right, put a sign on both sides of some part of the gantry. Now this is just an artist rendering, so it's not the real crane. Let's see if we can import a picture of the real portion of the gantry. I thought I brought a picture with me. All right, sorry for the boring delay. Maybe I'll edit it out. December, nope, we're going January of a new year. Here we go. And here's some pictures. Of course, I can't get a preview, so I'll bring all four in. Why not? Yes. There we go. There we go. There we go. Okay. So, here it is right here. I don't know what to call it. Crane gantry. Here's my survey guy's piece of paper and his tape measure. And he's in the yard at the crane company. And here's the other side. He's done a good job surveying this thing. And here's his survey right here. So, I guess my first thought was to put his survey down in detail to scale. Yeah, duh. That'd be the first move. So, on page 1, we present the finished product. The sign on the crane gantry on page 2 is an extrapolation of his survey to scale. Guess I'm not showing what scale it is. So I have to pick a dimension here like 77 and change my scales until I found the right scale. It's probably going to be, I don't know, 3/4. Nope, it's going to be 3/8. Nope, 1.5 inches. 1.5. Okay. Change to 1.5 scale. Now, I guess if you're watching, you should be familiar with Corel. Nope, I was going the wrong way. My bad. 3/8. And I guess you're going to get used to listening to me ramble. There it is, 77 right there. Okay, so now I'm in the right scale. 3/8 of an inch equals a foot. Maybe put that down on the paper so I don't forget. All right. I might show you a few Corel tips along the way. You know, whatever. But here's our crane gantry. Okay, back again. I had to take a break, and I'll probably be doing that often. I forgot to tell you one important thing that the salesman told me. When I went to ask him a question, he said, oh, by the way, they will not let you drill on this crane at all, so there will be no drilling on their crane. So you've got to figure out some way to, he said, quote, clamp the sign to the crane gantry. And I went, oh, let's just clamp it to the crane gantry. What exactly do you mean? He goes, I don't know. You're the engineer. You figure it out. So anyhow, back to where I began. The survey tells me these are 3.5 by 3.5 square tubes. Got to be steel, even though the survey doesn't say that. These are 7.5 by 7.5 square tubes. You can see from the picture. Steel again has to be. I had a hard time figuring out what these are. And a little bit of a hard time figuring out these dimensions. 1.5-inch pipe. 23.25 would be the distance between here and here, and 23.5 would be from here to here. You know, I guess center line to center line on these 1.5-inch pipes. I mean, I don't know. You go back to the pictures, which I already deleted. I don't know why I did that. Let's just bring in one for a reference. Maybe the good one. If I could get a preview, I guess I could switch here to view extra large icons. There we go. Pick out the one I like the best, which is this one. Leave it in here as a reference. Okay, these are the tubes right here and here. You know, there's some kind of round stock steel. I doubt they're pipes. You can kind of see how they're flattened over here and welded. This is probably where you attach your safety lanyard when you're walking down the crane. Anyhow, a lot of sign engineering is deciphering the survey you were brought, calling the survey guy and going, hey, what the hell is this? Anyhow, you know, it took me a minute to study this thing, and with the knowledge that I could do nothing but bolt our sign to their crane gantry, I started looking for, I don't know, something consistent. And what it is these 3 vertical square tubes. You know, make this the center line of your sign, and then you go out 108.25 in both directions. I said, aha, these 3 vertical members of the existing crane gantry are my foundation for my design. Now, you know, not only are there 3 things that I can use. Okay, I just drew a rectangle, but it won't come to the front till I Control G, group everything, and Control ungroup everything so that it's all on the desktop and will come to the front. Hope that makes sense to any Corel users. It should. Control D for a duplicate and Control D for another duplicate. So just for the fun of it, and I've colored them green just to stand out, here's my 3 things. Now, you might say, here's my other 2 consistent things. I can agree with that. A horizontal member, 2 horizontal members, certain distance apart from each other. So I can deal with that. These diagonals don't really come into play as far as my design. These horizontal round stock steel pipes, whatever you want to call them, they don't really come into play, but I've drawn them in because I'm going to have to stay away from all that. And see, since these are 7.5-inch square tubes and these are 3.5-inch, you know, the plane of my attachment of this sign is going to be the face of these verticals in between these 2 horizontals. Hope that makes sense. It will in a minute when I switch over to SolidWorks, because the next thing I said to myself was, I'm going to draw this bad boy in SolidWorks. It's simple. It won't take long. And I did. Okay, so this is called crane surveyed. If I hide everything else, then you can see the surveyed crane. The surveyed crane. I guess I gotta hide all my mirrored components. You know what? Sorry. Easier than hiding all this, now that I'm learning to use SolidWorks correctly, and I hope you are too. I feel like it's still 100% worth the investment. I'll just open this part. Duh. And that is my surveyed crane. Okay. And what I like about SolidWorks, of course, a lot of things, is that it's accurate. Super accurate. Okay? So I had this to begin with, and then of course I had my sign that has to go on there, which exists of this assembly. Let's open the subassembly. There it is. Now these are illuminated channel letters, simple product, on an ACM contour background. I personally would have made this 1/8 inch aluminum and not ACM, but I think someone's trying to save some money. I don't like ACM. I don't like it. I don't like it at all. Alucobond. Yeah. It's too easy to damage while you're handling it. Don't get me started, okay? Too late. Okay, so I like to think I'm, fairly good at engineering signs, designing signs, drawing signs, building signs, installing, thinking, servicing, but I'm a pretty lousy YouTube video maker, so bear with me. Anyhow, I'm going to go page by page on this drawing, this Corel drawing, and show you probably what I should have already shown you before we went down the rabbit hole in SolidWorks. But, number one, you got some dimensions to this sign. The survey revealed 77 inches in between these horizontal crane members, and so we're making the sign fit there. And the salesman told us we can't drill on the crane structure. I guess I also forgot to tell you guys that the general contractor is going to install this sign himself. Oh, joy. Letting someone else install a sign that you built. Then anything that doesn't go their way, they're going to blame it on you and your sign, not themselves. Now, a GC is a little bit better than just the end user, the customer, but geez, don't let someone else install the sign that you built. If they cannot afford the installation, then they need to go away. That's my humble opinion. Thank you. Anyhow, you can see the ACM is in front of the horizontal 7.5 by 7.5 steel square tube crane gantry member. So you got to take that into consideration. But this is the size of the sign that got sold. Okay? Deal with it. And you want somebody to build it, you got to identify these sizes. Overall width, overall height of the sign, maybe height of a letter. It's still a vector file, so they're going to use it in fabrication. After it leaves my desk, it goes to the CAD/CAM department where they create cut files for the router tables, the channel letter bending machine, the returns on the letters. I don't think you'd be watching this video if you didn't understand most of that. If you're still watching it and you don't understand any of that, then you must be really bored. Okay. Anyhow, there's the surveyed crane gantry. We've talked about that a little. And here's the plan. The plan in 2 dimensions. 2D. You know, I found these square U-bolts on McMaster car over here. 2 different sizes. Of course, I determined this was the size we would need. Missing some of the information like the McMaster car part number. This is simply a PDF downloaded off McMaster car. But anyhow, I thought this will work. We can just bolt around the 3.5 inch existing steel square tube on the gantry. We'll build a subframe behind the letters out of 2x2 1/8 inch wall aluminum square tube, and we use the square U-bolts 4 times on this vertical member and 4 times on this vertical member and 2 times on the center vertical member. Then I'll take a 3/8 inch bolt and I'll go through the back of the letter, which will be 080 aluminum, through the ACM contour background and bolt it to the subframe, the 2-inch aluminum square tube subframe. I'll even go further than that, and I'll catch an 1 3/4 by 1 3/4 aluminum angle stringer on the back of the gantry. So, you know, in essence, I'll have a stringer back there to catch some more bolting attachment points. Since I cannot use the square U-bolt from this point to this point, not until I get back into the open air here. So I have to bolt my sign to my subframe, and in certain places keep going with a long enough bolt to catch a horizontal stringer on the top and the bottom. Now, that's hard to understand unless you're real good with 2D. Here's the back side of it. You know, these are illuminated letters with LEDs in them. Actually, here's the LEDs still left in this particular view. So here's my power supply box. Had to find a place for it. Don't want it to stick out and somebody snags themselves on it as they're walking down the center of the gantry. Anyway, I hope that makes sense. Let's go to the next page. It will when we get back to 3D. Here's a cross section of the attachment. It helps a lot of people make sense of things. I mean, it's the only way you're going to communicate to the shop, what am I supposed to be building? You know, elevation drawings, cross sections, and then if you can throw some, you know, isometric drawings in there, coming from SolidWorks, everybody can go finally, ding, I get it, I see it, I get it. So here's the existing 7.5 inch steel square tube on the crane gantry. Here's the existing 3.5 inch steel square tube, and here's our square U-bolt. Here's our 2-inch aluminum square tube subframe. Here's our ACM, Alucobond, whatever you want to call it. I should have indicated that in places it goes above. It's taller than the distance between the two 7.5 inch steel square tubes. I'm even contemplating some kind of a rubber baby buggy bumper on the back of my subframe to make sure I clear here and touch here. Now that's where you have to be able to see what's going to go on when someone's putting this thing together, installing it. What are they going to go, crap, It's touching here, but it's not yet touching here. The reason I say that is this is 7.5, this is 3.5. That should be 2 and 2. That's if this is welded in the exact center of this. I sure hope that makes sense to anyone listening. You know, it's the kind of stuff I have to think about all day long, and if you don't think about it, it bites you in the ass. Anyway, one of the main reasons I'm even taking the time to share this project is to show again how valuable SolidWorks is. Big fan of the SolidWorks. Let's keep going. Okay, there's my subframe, my 2-inch subframe, and my 2 aluminum angle stringers on the backside. Again, hard to see, but has to be shown because it has to be built. Here's my letters. The LEDs we're using are GE Tetra Power Max. This is how many modules are in each letter, and you can run the whole thing on 100-watt power supply. Again, boring stuff. You should be used to it on a daily basis if you're watching this video. But if you're not, maybe I'll come back and do a separate video or something to help you understand that better. Next page. The BOM, the infamous BOM, which they love to have us dissect the whole thing into parts. How many parts? What parts? How many quantities of each? Boring, but you know, it helps the money managers crunch it, maybe, if they can keep up with the flood of information. That's a whole nother discussion. And there's the artist's proposed rendering on the wrong crane, but you know, close enough to help the customer go, yeah, awesome, I'll buy that. You know, I'm not sure if this is ever going to make it, you know, to the YouTube or not, but I don't know. It was still therapeutic or cathartic, whatever the word is, for me to make it and think about sharing engineering strategies with other sign men, especially the use of SolidWorks. So let's get back to that. That's the good part. All that background noise was to bring us to this part, and now I'm losing my momentum, my desire to finish this video. I don't know what that's all about. Many sign men are really great at starting things, but lousy at finishing them. Of course, when we go to work and they're whipping us, we have no choice but to finish things. So that's probably a good thing too. And then that way we get a lot of things done. Since I haven't put out a lot of videos, I'm going to have to keep telling people until they get used to the idea that Sign Man Matt has been in the business for 37 years. Literally been involved in not hundreds of signs, but thousands of signs. So, not bragging at all, very humble in what I do. I make mistakes every day, and I have people that are way better than me surrounding me, and I have people that are dumber than a rock involved on an everyday basis with me, but we still have to get the work done. And if you can relate, then you're a sign man too. If you can say I'm a sign man with pride, then you're a sign man, or a wannabe sign man, but you may turn into a real sign man. You know, one of the worst insults, put downs I could say to anyone is, quote, "You ain't no sign man." You know, that would hurt me, cut me to the core if someone were to say it to me. I would know it's not true, but it still is one of the worst things you can say to someone. And then to say the opposite, like, "You, quote, are a hell of a sign man." Yeah, that's one of the highest compliments I can think of. After 37 years in this business, it's in my blood. It's in there, and it ain't coming out. Anyway, sidetrack rant. Sorry. Let's get back to it. So, using the SolidWorks, I was able to create the sign. And SolidWorks is always drawing in real size. So we've got 080 backs. We've got 040 returns. Completely accurate. We got 6mm ACM, Aluca bond, and we've created a subassembly called channel letters on an ACM background panel. They're a subassembly, part of my final assembly, which is the entire sign shown on the crane gantry, including my McMaster car square U-bolts. Okay, the part I love about SolidWorks is the accuracy. Okay, this is my 2-inch subframe, and these are my McMaster car square U-bolts. This is my 1 3/4 by 1 3/4 by 3/16 wall aluminum angle stringer on the back side. And yeah, it's real. It's easy to see now. It's easy to see. Love it. In fact, there's an exploded view, Control 7. Let's get back to the isometric view. Go over to the configurations and explode everything. Sign consists of the existing steel gantry, the 2-inch aluminum square tube subframe in purple, the sign subassembly, the letters on the ACM background, contour background panel, and the 2 stringers. Then the square U-bolts. I'm not showing exactly the same amount yet. I'm not showing any in the center yet, but I'm going to continue. If I have the energy and the desire to take this thing to the finish line, and then I'll be back to show you. But